example that requires the application of relative acceleration equation under planar kinematics of rigid bodies. In applying the relative acceleration equation, the 2 points used in analysis, point A and point B, should generally be selected as points which have a known motion. So, as you can see in the figure given, we have points A and B on rod AB. Point A has a given acceleration of 5 meters per second squared and a velocity of 6 meters per second at the instant shown. So now we need to calculate for the angular acceleration of the rod and the acceleration at B at this instant. Here's the solution. First, we have to find the angular velocity of the rod at this instant. Locating the instantaneous center, IC, for rod AB, we can determine then that the angular velocity is equal to the velocity of point A, V sub A, over the radial distance of point A to the instantaneous center, R sub A relative to IC. Given the velocity of point A at 6 meters per second and an instantaneous center of 3, we have an angular velocity of 2 rads per second. Since points A and B both move along straight line paths, we can assume that the acceleration of point A is equal to negative 5j meters per second squared, while the acceleration of point B is equal to a sub b I meters per second squared. Applying the relative acceleration equation, we have the acceleration of point B, a sub b, is equal to the acceleration of point A sub a, plus the angular acceleration multiplied to the position vector of B relative to the reference of A, denoted by R sub B with respect to A, minus the angular velocity multiplied by the position vector of B relative to the reference of A. In calculation, we have a sub vi is equal to negative 5j plus the angular acceleration k multiplied by the quantity of 3I minus 4j minus 2 squared multiplied to the quantity of 3I minus 4j. Simplified would be a sub bi is equal to negative 5j plus 4 multiplied to the angular acceleration k multiplied to 3 angular acceleration j minus 2 squared multiplied to the quantity of 12I minus 16j. So using this, we come up with the acceleration at p and the angular acceleration. By comparing the acceleration j minus 2 squared multiplied to the quantity of 12I minus 16j. So using this equation, we can solve for the acceleration at p and the angular acceleration. By comparing the I and j components, we come up with the acceleration of p is equal to 4 multiplied to the angular acceleration minus 12, while 0 is equal to 11 plus 3 multiplied by the angular acceleration. Using these formulas, we arrive at the answers. The acceleration of p is equal to negative 26.7 meters per second squared going to the left, while the angular acceleration is equal to negative 3.67 radians per second clockwise. As in the analysis of the results in applying the relative acceleration equation, if the solution yields a negative answer for an unknown magnitude, it indicates that the sense of direction of the vector is opposite to the shown diagram. Thank you.
Good day everyone. So today I'm going to present a sample problem about planar kinematics of a rigid body. So the sample problem, the wheel of radius r 300 mm rolls to the right without slipping and has a velocity 3 meter per second of its center O. Calculate the velocity of point A on the wheel for the instant represented. So we have a given angle 30 degree, the radius 300 millimeter, the distance between point A and point O 200 millimeter, as well as its velocity 3 meter per second. So to calculate the velocity of point A, we can choose center O as the reference point for relative velocity equation since motion is given. So velocity A is equals to velocity O plus velocity A sub over O, since the relative velocity of A with respect to O is observed from the translating axis xy attached to O. Then the direction of relative velocity is perpendicular to OA. Thus, the angular velocity of OA is the same as that of the wheel. So to calculate the angular velocity, we can to calculate the angular velocity, we just divide the velocity, its velocity over its radius. So radius sa wheel. So the velocity 3, which is 3 meter per second, divided by the radius, which is the 300 millimeter converted into meter, that would become 0.3 meter. So 3 divided by 0.3, the angular velocity has the value of 10 rad per second. Since we have the angular velocity, we can now calculate the velocity of sub of A over BO by using the formula of velocity of A over B is equals to R omega. So ang R is gamiton is the distance between point O and point A, which is the 200 millimeter, times the omega, which is the angular velocity 10. So 0.2 times 10, that the velocity of A over O is equals to 2 meter per second. So with this, we can now calculate velocity of A from law of cosine. So velocity of A squared is equals to 3 squared plus 2 squared plus 2 times 3 times 2 cosine 60 degree. That would be equal to 19 meter per second squared. And to eradicate squared, i-square root lang siya. So velocity of A is equals to 4.36 meter per second. And the other way of pagpangita sa velocity A, makagamit po ta sa point C, since momentarily point C has zero velocity. So velocity A is equals to velocity C plus velocity of A with respect to C is equals to velocity of A over C, and velocity of A over C is equals to line AC times the angular velocity is equals to line AC over line OC times the velocity. And to get the line AC, we have here 200 sine 30 plus the quantity of 200 cosine 300 squared plus 300 squared, that would be equal to line AC is equal to 436 millimeter. So for convert this 436 millimeter into meter, that would become 0.436 meter over line OC, which is the radius 300 millimeter into meter, so 0.300. So 0.436 divided by 0.300 times the velocity of A over C is equals to 4.36 meter per second. And since velocity A is equals to velocity A sub A over C, so we can get that velocity A is equals to 4.36 meter per second. And that would be all. Thank you.
I'm G. Dominic, tag-1 sa BSc A2C. The sample problem is load B is connected to a double pulley by one of the two inextensible cables shown. The motion of the pulleys is controlled by cable C, which has constant acceleration of 9 inches per second squared and initial velocity of 12 inches per second, both directed to the right. The question is determine the number of revolution executed by pulley in 2 seconds. Then ang ikaduha, the velocity and change in position of the load B after 2 seconds. And then ikatulo, the acceleration of point D on the heart of the inner pulley at time is equal to 0. Solution. Motion of pulley since the cable inextensible, the velocity of point D is equal to the velocity of point C, and shall component of the acceleration of D is equal to the acceleration of C. These are the given. VD is equal to VC, and then BC is equal to 12 inches per second. Then ang ADT is equal to 9 inches per second squared. Noting that distance from D to the center of the pulley is 3 inches. So, na to. VD is equal to RW 12 inches per second is equal to 3 inches W. Then W is equal to 4 rad per second. AD is equal to RA 9 inches per second, so it's equal to 3 inches acceleration. Acceleration is 3 rad per second squared. Using the equation uniformly accelerated motion, we obtain for t is equal to 2 seconds. W is equal to W plus acceleration times time is equal to 4 seconds squared plus 3 radius seconds squared times 2 seconds is equal to 10 radius per second. W is 10 radius per second. Theta WT plus 1/2 acceleration times time squared is equal to radius per second times 2 second plus 1/3 3 radius per second squared and 2 seconds squared is equal to 14 rad, and then theta is 14 radius. Number of revolution is equal to 14 radius times 1 revolution divided by 2 pi radius is equal to 2.23 revolution. Then moto ang motion of pulley. Then ang letter B, motion of land B. Using the following relation between linear and angular motion with R is equal to 5. The formula is VB is equal to RW. RW is equal to 5 inches times 10 rads is equal to 15 inches per second. Then ang VB 15 inches per second. Then ang YB is equal to R theta. Triangle YB ay kanang triangle sumpay na dire sa Y. Then R theta is equal to 5 inches times 14 rad just equal to 70 inches. Then the YB is equal to 17 inches pa saka. Then ang C, acceleration of point D at time is equal to 0. The tangential component of the acceleration is ADT is equal to AC 9 inches per second squared. Since at time is 0, W rad is ang W is equal to 4 radius per second. The component of the acceleration AD is equal to RDW squared equals 3 inches 4 radiuses times 4 radius per second squared is equal to 48 inches per second squared. AD is equal to 4n per second squared. The magnitude direction of the total acceleration can be obtained. Tan theta is equal to 48. Butan lang natin 48 inches per second squared times 9 inches. Itong given ka ganina sa problem. 9 inches per second squared is equal to ang tan theta. Ang theta is 79.4. Then sin 79 is equal to 48 inches. Sin 79.4 degree is equal to 48 inches second squared. Then ang acceleration nato is 48.8 inches per second squared. Then we write A is 48.8 inches per second squared, and then the theta aning kuan kaning angle aning kuan diri as illustration is 79.4 degree. That's all.